So the topic for today is record classes in Java. So what is a record class? First of all, it is a class. So just as you define a simple class and get a new type, you can use the same with defining a record class, just that instead of using the class keyword, you use the record keyword, just as you can see in this code sample, very small one. The purpose of record classes in Java is to simplify the use of objects for representing data. Whenever we need objects just for representing data, think about data coming from database, data coming from a microservice, or data your microservice works on. In those cases, instead of defining a class and then define all the standard methods, equals toString, hashcode, and so on, you can define a record class. Just use the keyword record instead of class, that's all. And by doing so, you will get a new type. And that new type, which is actually a class, will include auto-generated fields in accordance with the definition of the record class. Here, for instance, if you take a look at this code snippet, you can imagine a new class, a new type that its name is book, that each and every object that is instantiated from that type has 3 fields: ID, title, and author. In addition, you get those fields defined implicitly as final fields, final variables, meaning that it is not possible to change their value. In addition, those fields will be automatically or implicitly private. And just in order to allow you to access those fields, there are methods that will be auto-generated for you, a method you can use for accessing those fields, as I will show you shortly. Let's take a look at this code snippet. So, well, let's define a new record. Let's call it, as you can see, we already have in IntelliJ the possibility to use record. And when I define the record, I just specify the name. So we already have a code sample for the record book. Let's think about something else. Think about immutable data. Usually we work with immutable data. So it can be, let's say, car. A car has a brand and a ID. So car, this will be the new record. And the fields, I want each and every object instantiated from this new type. The fields will be ID and brand. By doing so, we indirectly get auto-generated additional methods we can use when working with objects of this new type, just as it happens over here. Just that over here we have a few more things. So when working with an object that was instantiated from a record, and instantiating a new object from a record is very simple. It is the same as with instantiating a simple class. We just need to use the new keyword and then the name of that record we defined, and then pass over the values. In this case, it is just the ID of the car and the brand. That's all. And then if we want to access those fields, ID and brand, every car object, as we just need to invoke those auto-generated methods that were generated for us. For instance, if we want to type the brand of the car, we just need to write a car dot and call the brand method. That's all. Now, if we execute this code sample, we can have Toyota printed to the screen, to the console, as you could see. So if we want to summarize, when we declare a record class, we specify a sequence of fields. Then automatically for us, based on those fields we specified, we get auto-generated for us the methods equals hashcode and toString. They are automatically generated for us in accordance with the fields we specified. In addition, for each field we specify, we get automatically a new instance variable marked with the final keyword and the private access modifier. So here, for instance, we can imagine that every car object has two instance variables, ID and brand, and both of them are private and final. And as we have just seen, for each field, we get an auto-generated method for accessing and getting the data of that field. And in addition, we get auto-generated for us a simple constructor we can use in order to instantiate the new type we created. So basically, it is very simple to use records. We just need to use the record keyword instead of class. And then we just need to be aware of what we got. And what we got is a new type that its purpose is to simplify the use of objects for representing data. So if, for instance, we have a new record, the name is car, it is in order to help us working with objects that represent cars. The help comes through the auto-generated methods and through the fact that the fields every object has are final. Usually when we work with objects that represent data, it is better to have objects that are immutable, that the data they hold is immutable. This way, we shall have less complex scenarios in which we might have bugs. This way, we shall also get simpler code to maintain and to understand. Okay, so if we still want to have our own explicit constructor, it is possible. Maybe there are a few more things you want to take place when a new object is instantiated. So it is very simple to define our own constructor to take the place of that auto-generated one, as you can see over here. It is also possible to stay with the auto-generated constructor and just add some specific code segments, specific things we want to take place before the object is created, is instantiated. So for instance, if we want to remain with the auto-generated constructor and we just want to have a simple validation to verify that ID, for instance, is not negative or something else, we can do something like this. And when doing so, it won't be possible to refer ID. It will be only possible to refer the parameters, the fields we specify in the definition of the record. It is also possible to implement those access methods as you can see over here, we have the definition for the record book. We also have a definition for our own constructor instead of the default one, just to show that it is possible. And over here, you can see that I define the access method, the one we use for getting the value of a specific field, in this case, the ID field. So it is possible if you need, for some reason, having log messages generated whenever the ID is retrieved from a specific book object, then you can just redefine your own version for the access method. And pay attention, the names of those access methods, the names are the same as the names of the fields, you can see. So we actually have 3 access methods for getting the values of ID, title, and author. The auto-generated hash code, toString, and equals methods, we can still define them by ourselves if we want. Usually, I don't see a need for redefining equals and hash code. Usually what we get is enough. Regarding the toString method, it is a different case because sometimes we use those toString methods for detailed text that describe specific objects in log messages we generate, our project generates. So it might be useful to redefine our own version for the toString method instead of the auto-generated one. We can add to our record class static members. It can be static variables, static methods, static blocks, static nested classes. If you are familiar with that type of classes, we can do so. However, it is impossible to add new instance variables. We are limited to those instance variables every object has in according to the record definition. Every object instantiated from a specific type that was defined as a record will have those fields that were included in the record definition, those fields as instance variables only. It is not possible to add new instance variables to the record we defined. Static variable, it's not a problem, but instance variable, it is a problem. Okay, this is, I've just summarized for you. Regarding nested classes, as long as it is a nested class that is not an inner class, then it is possible. If you're not familiar with these topic, nested classes and inner classes, you can find a detailed course I prepared for this topic on Udemy. Native methods is not possible. We cannot add to our record definition native methods. For those who are not familiar with a native method in Java is a method that its implementation is not in Java. You can define a class and include within the definition of the class a method marked with the native keyword. The implementation will be outside of Java. It will be usually in C++, for instance. It is a mechanism that allows us to write code in Java that use or executes code in C++ whenever we need performance. If you, for instance, develop a voice over IP system, then you will probably need this type of method. So bottom line, when you define a record class, it is not possible to include the definition of native method, and it makes sense. We don't need it when we use records. Record is for simplify the use of objects for representing data. This is the purpose of records. The class that is automatically generated when we define a new record, the record class, is final, which means that it is not possible to define a class that extends a record class that we defined or someone else defined. So it is not possible to extend a record class because it is automatically, or let's say implicitly, a final class. You can define a local record class. If you are familiar with the topic nested classes and inner classes, then you can define a nested class, which is actually a nested record class, even if it is within the scope of a method, which means that by doing so, you actually get a local record class. It can even be a private one. Regarding serialization, if you are familiar with the possibility to serialize objects in Java, meaning decompose object into bytes and write those bytes to a file or send them somewhere, and also doing the opposite direction, meaning getting bytes from a file or from a specific resource and compose together the object. This is the meaning of serialization. So it is possible to serialize record classes, objects that were created from a record class, but it is not possible to change the default behavior of the serialization mechanism when dealing with record classes. Well, I believe that today using this mechanism is less popular. It was relatively popular 20 years ago. Today, usually we don't use it in order to pass over data over the web to another system, data that describes a specific object. We usually use formats such as JSON or XML, but I'm just saying that serialization is possible, but you cannot change the default behavior as you can when using single classes in Java. And one more thing, there is a class that its name is record, java.lang.Record. The record class you define implicitly extends this specific class, just letting you know. And that's it. Wow, it was fast, nearly 20 minutes.